Good evening, everybody. So I'll continue with our discussion of confidence interval for mean. And the formula that we used for confidence interval for mean is this, X bar plus or minus margin of error, where E is Z sub alpha over 2 times sigma divided by square root of the sample size. And this is for the case, remember PMS, we talked about PMS, proportion, mean, and standard deviation. We did confidence interval for proportion, now we're going to do it for mean. But for mean, there are two cases, when you know sigma and when you don't know sigma. If you know sigma, you use the standard normal distribution z-scores, okay? And if you don't know sigma, you use student t-distribution. Two different distributions you use, depending on whether you know sigma or you don't. All right, now we have done this problem last time, but I'm gonna go ahead and do it again, all right? So this one, according to USA Today College, an American college student studies 17 hours per week with population standard deviation 4 hours. You would like to know if a similar trend is present at your school. So you surveyed 100 students and found that their weekly average is 15 hours. Create a 99% confidence interval for the population average for your college. So as you read the problem, one of the things may get mixed up is this 17 and this 15. This 17 is something that's given by the by the USA Today. Okay, that's what's given by USA Today. That you can kind of assume that that's your mu 17. We really won't need it. Now, you want to test it for your school in a way. So you took a random sample of 100 students. So your N is 100. And your X bar is 15, like 15 hours. And also they have given you sigma is equal to 4. We need to create a 99% confidence interval. So my confidence level is 0.99. My significance level alpha is 1 minus 0.99, or alpha is equal to 0.01. So alpha over 2 is equal to 0.005. Now we are going to go ahead and draw a typical diagram, which is the standard normal distribution. This is 0, this is 1, and my area on the right tail is 0.005, and area on the left tail is 0.005. Okay. Now, if you look it up in the standard normal distribution table, this is going to be negative 2.575, and this is going to be positive 2.575. So that's your alpha over 2 or alpha, so I mean not alpha over 2, z sub alpha over 2, which is z sub 0.005, and this is your negative z sub 0.005. Now you can calculate the confidence interval, but in order to do that, you need to find the margin of error, which is z sub alpha over 2 times sigma divided by the square root of the sample size, which is going to be 2.575 times sigma. Sigma is 4 divided by square root of the sample size, square root of 100. If you simplify it, it comes out to be 1.03. Now, let's go ahead and do this. Margin of error, we found it. Now, confidence interval, CI, is going to be X bar plus or minus the margin of error. So X bar, we found it to be 15, okay? 15 plus or minus the margin of error is 1.03, which is gonna be equal to 15 minus 1.03, comma 15 plus 1.03. If I simplify it, it's going to be 13.97, comma 16.03. So for your college, your confidence interval at 99%, okay, at 99% confidence level, your confidence interval is between 13.97 and 16.03. That's what the interval you found. You are 99% confident that the true population average, true average number of hours your students, your college students study falls between 13.97 and 16.03. Okay, that's what it is. Any question, guys, on this problem? This is the second time I'm doing it, so. Anyone, any question? All right. If no question, then I can move on to the next problem. So, Mr. Zuckerberg, the founder of Facebook, recently announced that an average person spends 50 minutes per day on Facebook, Instagram, and Messenger. Assume that the time spent on these social networks are normally distributed with the population standard deviation, sigma, right? Hold on 1 second, my technology is betraying me. Okay, so sigma is equal to 30 minutes, right? To find out where the population mean reside, you survey 200 people. That means your sample size is 200 with the average. So there's the average from the sample X bar is equal to 45. Based on this survey, create a 95% confidence interval. So your confidence level is 0.95 or 95%. Alpha is equal to 1 minus 0.95, which is 0.05. So alpha over 2 is going to be 0.025. Now we draw the diagram, right? We draw the diagram and let's go ahead and draw it. Okay. Mean 0, standard deviation 1. Area to the right tail is going to be 0.025. And area to the left tail is going to be 0.025 as well. So this value is the z sub alpha over 2 negative 1 positive z sub alpha over 2. And this is a standard value, which is negative 1.96. And that's positive 1.96, right? Now I can find the margin of error, which is going to be z sub alpha over 2 times sigma divided by the square root of the sample size. So z sub alpha over 2 is 1.96 times sigma is 30. Sigma is 30 from the problem, divided by square root of the sample size, which is 200. And if I do the math, what do I get? 30 times 1.96 divided by square root of 200 is 4.15. If I round it, it comes out to be 4.16. So your margin of error is 4.16. All right. And that's what it is. Now, your confidence interval is going to be X bar plus or minus margin of error. Your X bar is right here, which is 45. Plus or minus margin of error is 4.16. So that is going to be 45 minus 4.16 comma 45 plus 4.16. If you simplify it, it's going to be 40.84, right? Comma 49.16. Okay, 40.84 comma 49.16. So you're 95% confident that the true population average falls between 40.84 and 49.16. So the actually, according to your calculations, which is based off of 200 randomly selected people, the average of Facebook or social media users is between 40.84 minutes and 49.16 minutes. And that is what it is. And 95% confidence level means if you were to create many confidence intervals like this using sample size 200, about 95% of those confidence intervals will include the population mean, and about 5% of those intervals may not include the population average. And that is exactly what this confidence level means. Anybody, any question on this problem?
I have one question.
Yes.
Just how did you get 1.96? That's the part I was confused on.
Remember, you look it up in the table for an area of 0.025. You look in the body of the standard normal distribution table and look for the value that is closest to 0.025. There is actually a value that is exactly 0.025. Once you find that value, you should be able to find the corresponding z-score. Look at the horizontal axis, that's going to give you z 1.9, and at the vertical is on column 06. So 1.9 plus 0.06 is 1.96.
Thank you.
Anybody else has any other questions? No questions? Everybody okay? All right. Then that's all for this one. Let's get to the next problem. According to Pew Research Center, on the average, an American reads about 12 books per year. So that's mu. You can think of it that way. According to Pew, the mu is 12, the population mean. And standard deviation is 6. Standard deviation, sigma is 6. You surveyed 30 people in your city. So you're comparing it with your city. So 30 people in your city and found that, so that's your sample size, n is equal to 30, and found that their average X bar is 10 books. Based on this information, create 90% confidence interval. So your confidence level CL is 0.90. So your alpha significance level is 1 minus CL, which is 1 minus 0.9. So alpha is equal to 0.10. Alpha over 2 is 0.05. Alpha is 0.10 and alpha over 2 is 0.05. Okay. Now, let's go ahead and look at the diagram, the one that we will create. Standard normal distribution, 0, standard deviation, 1. So area to the right tail is going to be 0.05, and area to the left is going to be 0.05 as well. Now again, these points, you look at the standard normal distribution table for 0.05 probability, the z-score is negative 1.645, and positive 1.645 by symmetry. So your margin of error E is equal to Z sub alpha over 2 times sigma divided by square root of the sample size. So my Z sub alpha over 2 is 1.96 times sigma is 6 divided by the square root of the sample size, which is 30. So that's going to give you 1.96 times 6 divided by 30 square root. That is 2.15. Okay. 2.1.
Wait, isn't it 1.645, not 1.96?
Oh, thank you for catching it. Who is it?
Camilla?
Camilla, thank you. I made the same mistake.
Yeah, I was about to say,
yeah, exact same
didn't
mistake.
I correct that mistake?
Was it you?
I think it was me.
Okay.
What a small world.
Why do I keep writing 1.96? Thank you. So that'll
Right.
change this number, right? Just because I did the last one, 1.96, I'm in that flow still. 1.645 times 6, right? And divided by square root of 30, that's going to give me 1.8. 1.8. So your margin of error is 1.8. And then confidence interval CI is X bar plus or minus margin of error. X bar is this number. Where is it? X bar 10. So 10 plus or minus margin of error is 1.8. So it's going to be 10 minus 1.8 comma 10 plus 1.8. That is going to be 10 minus 1.8 is 8.2, right? 10 plus 1.8 is 11.8. So the average number of books that people read in your city could be between 8.2 and 11.8, which may be a little lower than the national average, okay? That's that one. Any question on this one? Anybody? All right, let's clean it up. So according to www.textrequest.com, an American between 18 and 24 sends and receives about 128. So that's kind of like your mu text messages per day. Assume the population standard deviation is 30. So that's your sigma. So sigma is equal to 30. To get an idea about the true proportion to population mean, you take a survey of 100 people, so your n is equal to 100, right? You take a survey of 100 adults in that age group and find that their average is 120, so that means X bar is 120, okay? Create a 95% confidence interval, so it's gonna be confidence level is equal to 95% or 0.95. So alpha is equal to 1 minus 0.95. Alpha is the significance level. So alpha is equal to 0.05. So alpha over 2 is equal to 0.025. All right. Now, let's go ahead and create the diagram. Area to the right, 0.025. and area to the left, 0.025. And this is your negative z sub alpha over 2, positive z sub alpha over 2. Now, can anybody tell me what is the z value going to be here without looking at the table? Please don't look at the table.
1.96.
What is it?
1.96.
Perfect. Thank you. It is going to be negative 1.96 here and positive 1.96 by symmetry. So my margin of error is going to be E is equal to z sub alpha over 2 times sigma divided by square root of the sample size. Z sub alpha over 2 is 1.96 times sigma, which is, what is sigma? 30. 30 is given in the problem, divided by square root of the sample size, which is square root of 100. So it's going to be 5.88, I believe. 1.96 times 3 is 5.88. So your margin of error is 5.88. So your confidence interval is going to be CI, which is going to be X bar plus or minus margin of error, which is X bar is 120, 120 plus or minus margin of error is 5.88. 5.88, which is 120 minus 5.88, comma 120 plus 5.88. It's 120 minus 5.88 is, what is it? 14.12, I guess. 14.12, comma 125.88. So that's the confidence interval we are talking about. So 114, I am missing a 1 here, 114.12. So according to your calculation with 95% confidence level, right? The average number of text messages young adults receive falls between 114.12 and 125.88. And that's how you'd interpret it. Any question, anybody about this problem?
I think it's just straightforward, just the same as the other problems, except with decimals instead of, or not really, just this. It's just the same problem, yeah.
What do you mean? Can you clarify?
What I mean by decimals is that the E being 5.88, and not like isn't that's a 5.88, right?
5.88 is the margin.
Yeah. And it's like not like a regular problem or something, like a regular, like just a 1 or a 2 or 3, not a whole number. It's just like it's a decimal number, 5.88.
Yeah, it is.
Mm-hmm. Yeah, it's just yeah. That's all I wanted to say. Just a regular simple problem. We've been doing them, and they're just they're easy. Yeah, they're straightforward, and I like doing them.
Okay, good. Okay, so any question before I move on? No questions? Everybody okay? All right. Let's move on to the Next topic. So this ends the confidence interval for population mean when you know sigma. So what if you do not know sigma? In reality, in many cases, you really don't know sigma, honestly. The reality is that you don't know sigma. So in that case, what do you do? So the change is not much. This is actually what we have been using in terms of distribution, right? To create the confidence interval when sigma is known, which, by the way, if you look at it, it looks like central limit theorem kind of copy pasted here. Mu sub x bar is equal to mu, right? And sigma sub x bar is equal to sigma over square root of n. And this has a normal distribution with a mean of 0 and standard deviation of 1. So if we don't know sigma, by the way, we replace the sigma kind of by S, okay? Which is the sample standard deviation. And that leads to a new distribution. It's called student t distribution, okay? It is called student t distribution. All right, now what I want to do is this, talk about this distribution a little bit. This is a distribution that has a lot of practical importance, all right? Initially, the person who came up with this distribution, he could not publish his work because of regulations back then. If you worked for a company back then, your work, research work belonged to the company, not you. You could not publish it or anything. So he had to comply with it. But he actually published his work under the pseudonym student t distribution. Student, that's where the student comes from. Student t distribution. And that's why even to this date, we call it student t distribution, all right? So how does student t distribution look compared to the normal distribution? So this is the normal distribution, and this is the student t distribution. How does it look? So that's the next slide. And it's important for you to kind of see it enlarged so that you can go ahead and get a feel for it. So look, when n is equal to 30, sorry, this is the Z or standard normal distribution, the black, which is here you can see. When n is equal to 30, standard normal distribution and t distribution, they pretty much overlap. Look at these two curves. Look at these two right here. When n is equal to 30, sample size is equal to 30, they kind of overlap. However, if you go down on the sample size, t distribution start to deviate from the standard normal distribution. Even for n is equal to 20, it kind of looks like the standard normal distribution. When n is 5, you can see the distinction, this green one, n is 5. And the difference between this and the standard normal distribution is the tail, right tail and the left tail. In the right tail and left tail, you have more data points, okay? You have more data points for the t distribution. That means that's why it's above the normal distribution, okay? And for n is equal to 3, you can see the red one. It has even more data points here. So that is the comparison I want you to remember. Okay, that is the comparison I want you to keep in mind. Standard normal distribution and t distribution, they are extremely similar when sample size is closer to 30 or above, okay? If sample size is 30 or above, they're pretty much the same. But for less than 30, it starts to deviate from the standard normal distribution. How does it deviate? It has kind of like an extended tail, extended right tail and left tail. That means there is more data points around here for sample sizes less than 30. More data points to the right, more data points or more probability in a sense. Data points in this case translates to probability, more probability to the left and to the right. Now here is another diagram of the same thing. It's also kind of nice to see. See, for n is equal to 30, okay, or around there, the black is the normal distribution. So they kind of overlap. For less than 30, you have blue and red. You can see here how these tails are a bit more stretched and it has a bit more probability over there. So think from here and from here to the left and to the right. For normal distribution, you have less area, right? Just this. But for T distribution, you have that plus this, right? Let me use red, then you'll see it. That plus this. Plus. Okay. All right. Any question on this, anybody? How do you calculate the confidence interval for student T distribution? This is it, okay? This is how you calculate it. Compare this with standard normal distribution case that we have had Z sub alpha over 2 times sigma divided by square root of sample size. Exactly the same structure. Z is being replaced by T and sigma is being replaced by sample standard deviation S. Sigma is the population standard deviation. Other than that, everything is the same. So we are going to use this in this first problem. Assume that you'd like to, actually, you know what? Since the process is exactly the same, I'm going to just write down the formula here for you. X bar plus or minus T sub alpha over 2 times S over square root of N. Actually, I just switched my mind. I just realized that you don't have the tools that you need in order to do the problem, because you don't know still how to look up the T distribution table values. And then you need the sample standard deviation, which you don't know yet, and sample mean, you don't know it either. So let me just do the first problem, then you can try the second one. Assume that you'd like to know the average yearly income that the agricultural field workers in Salinas, California makes. So you take a random sample of 10 field workers and find the following incomes. So these are the incomes you found for 10 people. Remember, here you don't know sigma. Then you need to create a 95% confidence interval. So if you think sample size N is equal to 10, because you have taken data from 10 people. X bar, what is the average of these numbers? That X bar, by the way, is 17,340. X bar is 17,340. What is the sample standard deviation, which is 3515? I have rounded it, 3515. Now, how do you get this sample standard deviation? Of course, you don't calculate it by hand. The way you do it, go to Google and type in standard deviation calculator, standard deviation calculator. Do that. You'll find online standard deviation calculator, then just punch in these numbers there, and that'll give you the standard deviation. And along with standard deviation, it will give you the sample mean, or X bar, as well. So now let me go ahead and do the problem. So what we are going to do, we are going to create diagrams like normal distribution, but it is actually T distribution. And I'm going to stretch the tail a little bit just to give you a sense of T distribution. Okay. Now, so this is my T distribution. Now, area to the right and area is a 95% confidence level. So alpha is going to be 1 minus 0.95, which is going to give you alpha is equal to 0.05, and alpha over 2 is equal to 0.025. So area to the right is going to be 0.025, and area to the left is going to be 0.025. Now, how do you find this value and this value? Remember, this value is t sub negative t sub alpha over 2, and this is positive t sub alpha over 2. Alpha over 2 is 0.025, so this is negative t sub 0.025, and this is positive t sub 0.025. We need to find these values. To find the value, everybody, please do open the standard, T distribution table. There's the page number 7 in the handout. Everybody, please open it. Page number 7 in the handout. Page 7 in the handout. If you look at the handout, this is how it looks like. In the top left, you have degrees of freedom. 1, 2, 3, 9, 10. And here you have a few columns like this that tells you area in one tail, okay? And area in two tails. So in our case, area in one tail is 0.025, and area in both tails or area in two tails is twice as much, which is 0.05, because 0.25 plus 0.025 plus 0.025 is 0.05. Now, if you look at that column, so this is how you're gonna look. Your degrees of freedom, DF, is always defined as n minus 1, or the sample size minus 1. In our case, sample size is 10. So we take 10 and subtract 1, and that is 9. So that's my degrees of freedom. So I look at the degrees of freedom column and go to 9. That's gonna be my row. And then I look at the column where it says area in one tail is 0.025. Area in one tail, 0.025. Area in two tail is 0.05. And if you look at that column and look at this row, wherever they intersect, the point that you get, the number that you get, that is your T sub alpha over 2. And what is that number? What is that number?
2.62. 2.262.
2 point what? 262? That is correct. Thank you. That's negative 2.262. 2.262. So you just found your T sub alpha over 2. So you can calculate the margin of error is equal to T sub alpha over 2 times S divided by the square root of the sample size. So that will be 2.262 times S is 35, 15, all of it divided by the square root of the sample size, which is square root of 10. And let's do the calculation. 2.262 times 35, 15 divided by 10, 25, 14. So it comes out E is equal to 25. E is equal to 25, 14. Okay. So margin of error is 25, 14. So now your confidence interval is gonna be X bar plus or minus the margin of error. X bar is 17,340, this number. 340 plus or minus margin of error 25, 14. So it is going to be 17,340 minus 25, 14, comma 17,340 plus 25, 14. So what number do I get? 17,340 minus 25, 14 is 14,826. 14,826, comma 17,340 plus 25,14 is 19,854. 19,854. So based on your calculation, using the t-distribution at 95% confidence level, the average yearly salary for field workers falls between 14,826 and 19,854. And that's what it is. Any question, anybody? By the way, t-distribution table, I'm going to bring it up shortly. So I'm going to show it for the next two problems. I'm going to actually have the t-distribution ready, and you're going to look at the problems on the class slides, okay? Lecture notes. I want to show you the t-distribution table so that you can go ahead and figure out how to find the values on the t-table. Any question, anybody? All right, no question, everybody okay?
I think so.
All right. Now, let's go ahead and, yes?
Could you just repeat how you get S and X bar one more time?
Sure. S and X bar, you go to Google and look for standard normal distribution calculator. I mean, not standard normal, I meant standard deviation calculator. Sorry, my apology. Standard deviation calculator. If you search for it, you will find quite a few of them. So just go to one of those and type in the numbers in the problem. Like for this one, the same thing.
Okay, thank you.
And then it'll give you X bar and standard normal distribution. Actually, you know, I'm gonna teach you how to do it using Python. Okay, Python probably has a function that does calculate standard deviation. You don't have to go to Google. You can actually do it yourself using Python, because Python is so powerful that you can do so many things with this program. That's amazing. All right, so I want you to go ahead and read this problem, and then I will do it. So let's start on the next problem. Please look at lecture slide 160, okay? Look at that slide. So you'd like to know how much time on the average students spend per day on Facebook or / social media. You asked 15 randomly selected students and got the following data. So you got a bunch of data and create a 95% confidence interval based off of that. So your sample size N is equal to 15 because you asked 15 people. Now the average of the numbers X bar which you have to find is 44, and the standard deviation of the sample, okay, standard deviation is 19.89. So these two numbers you're gonna find by either using Python, and by now you guys know how to use the IPython notebook or Google Colab. I'll send you the command for finding the standard deviation for a data set. That way you can just use it and find the standard deviation. And along with that, I'll find how to find the mean in Python. So that way you'll be good. All right, so what is the confidence level they want? 95%. So alpha is gonna be 1 minus the confidence level, which is 1 minus 0.95. So alpha over 2 is 0.025. Now, if I were to draw this is the student distribution. Area to the right is 0.025 and area to the left is 0.025. All right. Now we need to find this value and these values. Area to the right is 0.025 and area to the left is 0.025. Now, your degrees of freedom, to find the area, we need the degrees of freedom, which is n minus 1, or the sample size minus 1. So it's 15 minus 1 is 14. So your degrees of freedom, df, is equal to 14. Okay, now you look it up in the table. So everybody pay attention. Your degrees of freedom column right here. You look down this and you get to 14. So this is the point we are looking at. Degrees of freedom, 14. Now, area in one tail is 0.025. Area in two tails is going to be 0.05. If we look at it, we can see right there. Okay. Area in one tail, 0.025. Area in two tails, 0.05. So let me just go ahead and erase this little bit because I moved the graph a little bit. So 14 is gonna be right here, okay? Degrees of freedom. Now, if you come down this column to 14, is gonna be 2.145. So this row and this column. So this is negative 2.145 and this is positive 2.145. Now I can go ahead and calculate it. So everybody, I'm gonna pause here and ask you, are you okay finding the value from t-distribution table? Anybody has any confusion on how to find that value from t-distribution?
I think it makes sense. I just I kind of missed a bit of the beginning, and I missed the part where you found that the X bar and the sample. This what was the sample? Is the sample deviation?
Oh, standard deviation, sample standard deviation.
Uh-huh.
That value you have to calculate it.
Okay,
Either
okay.
Google or using the commands that I'll be sending you.
Okay. So that's how you found it. That's how you found 44 and 19.89.
Mm-hmm.
Okay.
Right. All right. Now let's go ahead and clean this up a little bit. So my margin of error is going to be t sub alpha over 2 times s divided by square root of the sample size. T sub alpha over 2, we take the positive value, remember, 2.145 times sigma, which is, not sigma, s, which is 19.89, divided by the square root of the sample size, which is 15, okay? Now, if I do this calculation, 19.89 times 2.145 divided by square root of 15, that gives me 11 approximately. So that's 11. So margin of error is 11. So your confidence interval, CI, is gonna be X bar plus or minus E. X bar is 44 plus or minus 11, which is 44 minus 11, comma, 44 plus 11. That, by the way, is 33 to 55. So according to your calculation, the average number of minutes that students spend per day on Facebook or any social media is somewhere between 33 and 55. And how confident are you in your calculation? It's 95% confidence. Is this okay, guys?
Yes.
Yeah, it seems even easier than the first one, honestly. because we're
Okay.
kind of plugging in the first X bar and the S standard deviation.
All right.
Yeah.
Next one. So next problem is, you'd like to know how many hours on the average students at your school work per week, okay? So you wanna know how much students work per week. So you collected data from 17 randomly selected students. So your N, or the sample size, is 17. And if you did took the data and found the X bar and S, X bar is the sample mean, it would be 19.88. And sample mean, standard deviation, S, is gonna be 8.38, okay? All right, 19.88, and S is equal to 8.38. Now, let's go ahead and do this. So alpha is 1 minus confidence level, alpha is 0.05, because 1 minus 0.95 is 0.05. So alpha over 2 is gonna be 0.025. Again, we draw the t-distribution curve. Area to the right is 0.025. Area to the left is 0.025, okay? Area to the right is 0.025 and area to the left is 0.025. Now again, we got to find this point and this point. Our degrees of freedom, DF, is gonna be N minus 1, which is, N is 17 minus 1, which is gonna give me DF is equal to 16. Again, let's go ahead and look at the degrees of freedom column, which is right here. Where is 16? 16 is right here. We look at this row. And which column do I look at? Area in one tail, 0.025, area in two tails, 0.05. And if I go along this, I think this is the value. If you come down right here, 2.12. So this is negative 2.12. This is positive 2.12. All right. So let's clean it up and do the calculation. It's pretty standard. Once you understand the rhythm, is all of them are very methodical or mechanical, however way you say it. So margin of error is equal to T sub alpha over 2 times S divided by square root of the sample size. T sub alpha over 2 is 2.12 times S is the standard deviation, 8.38. 8.38, all of it divided by the square root of the sample size, which is 17. And if I did the calculation, it's gonna be 2.12 times 8.38 divided by square root of 17, that is 4.308, or is 4.31. So your margin of error is 4.31. Then your confidence interval is gonna be equal to X bar plus or minus margin of error. X bar is 19.88 plus or minus 4.31, which is gonna give you 19.88 minus 4.31, comma 19.88 plus 4.31. So 19.88 minus 4.31 is 15.57. 19.57, comma, 19.88 plus 4.31 is 24.11. 24.11. So true number of hours that students at your school work per week falls between 15.57 and 24.11 hours. Okay, 15.57 to 24.11 per hour, 11 hours per week. So that's 95% confidence level, or 0.95, right? See, all these problems are very mechanical, very similar. Once you understand one, you can get the others. You just have to understand the wording of the problem and take the numbers from the problem and do it. Anybody, any questions, anything on this? No questions, everybody okay? All right, that is all we will be covering for the midterm. And once again, we'll have a review for the midterm. To help you guys out, I'm holding this special review session Sunday at noon. I'll send an email as well about it, okay? So please go over the review problems that I'll be putting online, as well as the homework. I'm opening up old homework so that you can work on it and improve your score and so and so.
Are you gonna put the review questions today, or are you gonna do it on Monday?
Probably not today, by tomorrow noon.
Okay.
By tomorrow noon, I'll put it, okay?
Okay.
All right.
Thank you, and since we're not gonna see you till like, I
Monday.
guess Monday of the 22nd. I like to say have a good
Thanksgiving.
one.
Everybody, happy Thanksgiving.
Happy Thanksgiving.
Stay
Actually,
safe.
wait, on the 29th, huh?
Yeah,
the 29th.
Yeah. Happy Thanksgiving. Stay safe, stay healthy, and you know, do social distancing, wear mask, etc., etc.
Yeah.
Okay.
Have a good
Take care.
Thanksgiving.
Happy
Take
Thanksgiving.
care. Have a good one. Happy Thanksgiving. See you on the 29th.
Okay.
Wow, the 29th. We're almost done.
Yeah.
That's crazy.
Okay.
Have a good one.
Okay. Bye.